In the previous 3 videos, I have talked about the biological considerations, which are the first type of considerations that we should put in our minds during the preparation of the teeth to receive a restoration. And we have said that the biological considerations are the considerations that will take care of the health of the oral tissues. In these videos, I will I will talk about the second type of considerations, which are the mechanical considerations. The mechanical considerations are the considerations that we should put in our minds regarding how to retain the restoration to the tooth structure and how to keep the integrity of the restoration and prevents its deformation. And this thing will have 3 parts. The preparation of a tooth in a specific form that will retain the restoration against the vertical forces. This form is known as the retention form of the tooth, or the second mechanical consideration, is the tooth form that we make to prevent the dislodgement of the restoration from forces other than the vertical forces, or in other words, the horizontal or oblique forces, so that that form of the tooth that will prevent the dislodgement of the restoration or from forces other than vertical forces is known as the resistance form. And finally, the form of the tooth that will prevent the fracture of the restoration, and in the same time we should know that the last consideration, which is the integrity of the restoration or prevention of its deformation, will not only depend on the tooth preparation but on the restoration itself. And I will talk in details about each one of them. The first thing that I will talk about is the retention form, or the form of the tooth that will prevent the restoration from being dislodged out of the preparation by a vertical force. Before starting talking about the retention form, I want to talk about this thing. Guys, these are hinges, door hinges, and we must have sometimes seen that there are some dust on these hinges, and that dust prevents the proper movement of the metal parts of the hinges. And that is because the dust particles that are present between the metal parts of the hinges will increase the frictional forces between the metal parts of the hinges, and subsequently will decrease the movement between these metal parts. Okay? And this is actually a disadvantage of the frictional forces, but in physics they have told us that the frictional forces are indispensable in life and we cannot live without them. And actually this is right and true, because President Obama cannot run and play with his dog without the aid of the frictional forces that are present between his shoes and the grass beneath it. That is right and true in dentistry also, because the frictional forces also are sometimes bad, because when there is a friction between the two opposing teeth, that will lead to attrition. But in other situations, like when we want to retain a restoration to a tooth, we need the frictional forces of the physics to retain that restoration to the tooth. So that now you may think that the luting agent is the major part in the retention procedure of the restoration to the tooth structure. But actually that is not true. That is not true at all. Okay, the luting agent has a very minimal effect because of its little and minimal adhesion to the luted surfaces, but the major retention is done by the frictional forces between the restoration and the tooth, and the luting agent that increases these frictional forces, not the adhesion of the luting agent. No, the friction of the luting agent that will increase the retention to the of the restoration to the tooth. So that guys, it is obvious now that the luting agent adhesion is minimal and sometimes very minimal. For example, the zinc phosphate cement that has no adhesion to the tooth or to the restoration, so that at this time, how can he lute or act like a glue between the tooth and the restoration? No. In this situation, the luting agent just act or increase the frictional forces between the tooth and the restoration, and so that there will be retention. I have said that the luting agent has a very minimal effect, and that actually depends on the type of the restoration that we are using. For example, the reactive metals, like the base metals, are more or let's say have more retentive properties than the noble metals like gold, that are not reactive, so that they will not react with the luting agent and will not have an additive adhesion to it. And also it will depend only on the reactivity of the material, but on the material itself, what it is. For example, the resins are way much more retentive and adhesive to the tooth and restoration more than the glass ionomer cements, and then the zinc oxide diogenol cements, and then the zinc phosphate cements, which have the least adhesive properties to the tooth structure and to the restoration. Another example that we see every day, which is the floor tiles. Guys, the floor tiles or the ceramic that is present in the floor of our houses is luted by cements also, so that it's like the tooth, and so that the floor is like the tooth, and the ceramic is the ceramic restorations, and the cement between the tiles is like the luting agent or cementing agents of the restorations. The tiles are not seated in their locations by the adhesion of the cement to them. No, the cement will only increase the frictional forces between them and prevent their dislodgement. Okay? And if we want to talk about the factors that will affect this friction, the friction will depend on the roughness of the surfaces, and if we increase the roughness of the two surfaces, that will not be good, because it will make the work harder, like the impression taking procedure and the wax up procedures. These procedures will be more difficult, so that we should increase the roughness of the restoration from the inside. That will increase the frictional forces and subsequently will increase the retention of the restoration to the tooth structure. Also, the surface area. If we have tall preparations, if we have molars rather than premolars, complete coverage restorations rather than partial coverage restorations, of course, as of course, the more surface area, the more frictional forces present, and the more retention of the restoration to the root structure. The third factor is the force applied. And guys, luckily, the force that is applied on the tooth is way much more than the force that dislodges it. And what I mean is that the dislodging forces, for example, we have said at the beginning of this presentation that the retention force is the retention of the restoration against vertical forces, and the vertical forces here are the forces that are caused by sticky food, for example, chewing gum or a piece of caramel. These are the vertical forces, and they are luckily very minimal compared with the occlusal forces, which are very big and huge compared to them. So that in this situation, and it looks like the situation of the tiles, the pushing forces are way much more than the pulling forces, so that the restorations will be kept in their place. The same is for the tiles, floor tiles. If we apply a pulling forces on the tiles, for example, if there is a chewing gum that is attached to your shoes, that force is very minimal compared with the force of your foot pushing the tile. Okay? And the last thing or factor that will affect the retention and the retention of the restoration to the tooth preparation is the type and thickness of the cement used. And I have said that before, that the luting agent adhesion is minimal but not absent, and it's highest in the resin, adhesive resins, then in the glass ionomer cements, then in the zinc oxide, eugenol, and polycarboxylates, and then finally in the zinc phosphate cements, which have the least adhesion to the tooth structure and to the restorations. So that in the zinc phosphate cement we may completely completely depend on the frictional forces to retain the restoration to the tooth structure. And that friction should not only be present to retain the restoration to the structure, but it should have a single path of placement and displacement. Guys, if you look at the tile that is present on the upper left part of this picture, you can see that there is a fracture in its left middle part. As I have said before, the tiles are kept in their place as long as there is the cement between them that will increase the frictional forces between them, and because the pushing forces of our feet are more than the pulling forces of the water between the shoes and the tile, or the chewing gum that is present between the shoes and the tile, so that as long as the forces of pushing are more than the pulling and there is a cement and frictional forces, the tiles are kept in their place. But if we make another path for the movement of the tile other than the vertical path, because what we have said before is that the tile cannot be displaced vertically. But what if we make a path other than the vertical path, and that is because of the fracture? The fracture will allow for an additional lateral path rather than the vertical path. In this situation, the dislodgement of the tile and the movement of it will be easier. The same is applied in our teeth and restorations. Because if the restoration because the restoration must be kept in the tooth with frictional forces and in one path only. If it has another path, it will be dislodged and it will not be retained to the tooth structure. A simple example for that is the bolt and the nut. The nut has frictional forces to the bolt, and it has only one path of placement and displacement so that it can be retained to the bolt. But if the bolt has tapering, or it has a convergence or anything like that, yes, let's imagine if the bolt from the small end has a convergence. Of course, the nut will be easily displaced from it. Or let's imagine another thing. Let's imagine if a part of the bolt is fractured from the small end, the nut will be easily displaced, of course, because it has now a free movement, another path of displacement rather than the single path of placement and displacement that it has. And the same is applied for the tooth, as you can see here in the yellow picture illustration. The tooth must be cylindrical in shape with parallel walls, and so that then we will put the restoration in it in the same way, and here in this situation the frictional forces will play their role in maintaining and retaining the restoration to the tooth structure. But unluckily, this situation is not practical in dentistry, and we cannot make a preparation of a tooth that is completely cylindrical. And that is because if we make the preparation completely cylindrical, the seating procedure of the restoration will be very difficult. Not just that, but also the excessive cements will not be easily leaked out from the space between the restoration and the tooth, so that this situation is not practical. And because of that, we should do some tapering in our preparation, first of all, to eliminate the possibility of undercut happening, and then to allow for the excessive cements to leak out. Guys, do you know what's the meaning of tapering? Tapering is defined as the convergence of two opposing surfaces and if you can see the picture below, the ABCDEFG picture, you can see that the walls of the tooth has convergence, and that convergence is the tapering that I want to have. Okay, this typically ranges between 5 to 22 degrees. I have said before that we do not have the measure application that is present in our iPhones to have this specific and precise measurements. But because this measurement is very important, I wanted you to know that the 6 degrees is the ideal taper. We have said that we have a range between 5 to 22 degrees, and the best and the ideal taper is a 6-degree taper to have the best retention form of the restoration without impairing its retention, and to have the best escape and seating possible of the restoration without any impingement. This 6-degree tapering or inclination is exactly like when the minute hand of this $17 million Rolex passes 1 minute. Guys, from the 0 minute to 15 minutes we have 90 degrees, okay, and from the 1 minute to the 5 minutes we have 30 degrees, and from the 0 to 1 minute we have 6 degrees, because as you know, from 0 minute to 15 minutes we have 90 degrees. 90 degrees divided by 15 will be 6, and that is 6 degrees. Okay, this is mathematically calculated, and I wanted you to know that because this is very important to know the 6 degrees inclination and taper. Okay, and I have made this simple illustration to make you understand it more. Guys, the purple line is the preparation, is the prepared tooth, and the orange thing is the bare tip. You should know that the bare has an inclination and it is not even. That inclination is 6 degrees. So that by only putting the bare vertical around the tooth, it will spontaneously make the 6-degree tapering. Okay, you should not care about the tapering procedure at all, and you should not care about the margin geometry also, because the margin geometry that you want to do and the 6-degree tapering that you want to do is done completely by the bear itself. The bear head will make the margin design that you want. For example, here we have a rounded head that will make a chamfer finishing line or margin design. And we have an inclination in the bear. The bear is not even from below and going up, and that inclination in the bear will take from the tooth structure and make it convergent in a 6-degree manner. Okay, so that you should not do under tapering, because that will lead to the presence of an undercut like in picture A. And you should not also do over tapering like in picture B, because over tapering will lead to the case where, do you remember the fractured tile and how it is easily displaced? The same is here. When we are making an excessive tapering like in picture B, the restoration will be easily displaced from the tooth and the rotation will be impaired. Also, all the unsupported enamel must be removed during this procedure of putting the bear perpendicular or parallel to the tooth structure. So that, guys, now I think it is clear that the bear does all the work. It does the margin design and finishing line, and it does the tapering procedure and the retention form of the restoration, so that you should only catch the handpiece parallel. Look at the head of the handpiece that is parallel to the head or occlusal surfaces of the teeth. Okay, in this situation, when the handpiece is parallel to the occlusal surfaces of the teeth, you are working correctly, and the bear will do the work that you want, from making the biological considerations of the tooth preparation and the mechanical considerations of the tooth preparation. Just hold it vertically and steadily. So that the summary for the retention form, what I want you to know, I want you to know that the luting agent adhesion is very, very minimal. And if we only depend on it, that will lead to failure. Okay, and that is the third most common type of failures, which is the lack of retention of the restoration or prosthesis to the abutments after the secondary caries and after the porcelain failure. The third type of failures in the fixed prosthodontics is caused by the lack of retention. Why lack of retention? Because the dentist does not think in the mind of Zaha Hadid and know that there should be some mechanical considerations, and the preparation should be as cylindrical as possible with only 6-degree tapering, and that will lead to the retention of the restoration. He thinks that by haphazard preparation and putting the luting agent inside the restoration and then putting it above the prepared tooth, that will suffice the retention of the restoration to the tooth, but that is very wrong. Okay, so that we should not depend on the luting agent for the retention of the restoration to the tooth structure, but we should depend on the frictional forces between the restoration and tooth surfaces in one path only, of course, so that we will have a successful results. Okay, the second mechanical consideration is the resistance form. The resistance form is the preparation of the tooth in a form that will prevent the restoration from being dislodged by horizontal or oblique forces, or in other words, prevents its rotation. Guys, I will not talk a lot about this thing, but I will give you a simple example so that you will understand what we want to have in the preparation to be a resistance form preparation. Guys, this is a bottle of Pepsi. Let's imagine that the cap of this bottle equals to the restoration, and the bottle's head equals to the tooth preparation. Because the bottle's head is short and wide, so that the cap can be easily displaced and rotated from it. So that to have a resistance form, we should make the preparation not wide and tall, so that it should be taller than being wider to have a resistance form, so that the height that we want is minimally 3 to 4 millimeters long and as narrow as possible, as we said before, because the cap of the bottle of Pepsi can be easily rotated and displaced because it is wide, so that the preparation should be as narrow as possible and as tall as possible to have a proper resistance form. And again, 5 to 22 degrees tapering, and the presence of the proximal boxes as in the gray picture, and the presence of pinholes like in the yellow picture will all increase the resistance form and prevent the rotation of the restoration. And we should decrease the parafunctional and eccentric interferences. Decrease the eccentric interferences by having the proper occlusion, by removing any high spots or anything like that, and decreasing the parafunctional habits by the night guards or anything like that that will decrease the parafunctional habits. Finally, the use of a strong luting agent. If we use a strong luting agent with a high modulus of elasticity and high compressive strength, that means it will not be atomized easily, it will not be deformed easily, and it will work correctly and properly, and its particles will make the frictional forces that we want to retain the restoration to the tooth structure, both against the vertical forces and against any other forces horizontally or obliquely that tend to displace the restoration from the tooth structure. Okay, the last mechanical consideration is a tooth and restoration form that will maintain the restoration's integrity and prevents its deformation, and that is by having no stress concentration areas like in the principles of the tooth preparation to receive a filling, and that depends also on the type of the alloy and on the thickness of the alloy. We should have no stress concentration areas, or we should do beveling always as much as we can. As you can see here in these pictures, where we have done beveling in all line angles to prevent the stress concentration areas, which will act like a stab in the back of the restoration, and which will also uh, weaken the luting agent and fracture its parts, and decrease its function in increasing the frictional forces, and subsequently there will be less retention and more possibility of restoration fracture. So that beveling is very important during the tooth preparation. And the type of alloy, the gold alloys that are used in the fixed prosthodontics are type 3 and 4 ADA gold alloys, and we may also use the nickel chromium alloys that are stronger than the gold, of course, and so that they are used, as you can see in this picture, for the long span fixed dental processes. Okay, the last thing is the thickness of the alloy. Not just the type of the alloy will prevent its fracture, but the thickness of the alloy will prevent its fracture too. Or in other words, the adequate amount of tooth preparation will give it enough space, and so that it will be thick enough and strong enough to not be fractured. And that is summarized in this table. We should do an occlusal reduction, which will subsequently be the thickness of the restoration. For the all metal restorations, we should do 1 to 1.5 millimeter occlusal reduction. For the metal ceramic restorations and all ceramic restorations, we should do a 2 millimeter and 2 millimeter reduction respectively to have a good thickness of the restoration, while axially and at the finish line area we should do a reduction of 0.3 to 0.8 millimeters for the all metal restorations, 1 to 2 millimeters for the metal ceramic restorations, and 0.5 to 1.5 millimeters for the all ceramic restorations. This is the last slide about the mechanical considerations. In summary, what I want you to know, guys, is mechanically, and when you think like Zaha Hadid, you should know that the retention form of the restoration, or the form that will retain the restoration against the vertical forces, is gained by having a uh, as much parallel preparation as possible, to have as much frictional forces as possible, because the frictional forces is the thing that will retain the restoration to the tooth, not the luting agent. Secondly, the resistance form is the form of the restoration that will retain the restoration to the tooth against the rotational forces or horizontal forces or oblique forces, which is gained by the having the thing that is opposite to the Pepsi bottle of Pepsi head, which is the long and narrow with minimal tapering and proximal grooves and boxes and pinhole preparations that will prevent the rotation of the restoration and its displacement. Finally, we should have strong metals with enough thickness and no stress concentration areas beneath them so that they will not be fractured. These are the mechanical considerations regarding the tooth preparation. I wish that this presentation was helpful for you, and I wish that you forgive me if there is something unclear or something missing in this. And in the next presentations, I will talk about the last or the aesthetic considerations during the tooth preparation to receive a restoration. Thank you for improving yourself by listening to this presentation. Always try to know, spread knowledge, and construct the world. Be kind to others, and that is for the greatest benefit to the humankind.